So while thinking about this for a really long time, I was, thinking like, well, what would be the best way to encourage people to change their behaviors such that they're not so reliant upon this globalized system of distribution, where we can relocalize manufacture, and not only relocalize manufacture, but also use more ecologically sound materials in manufacturing. So we came up with this kind of multifaceted platform called the MandelBOT Surfa at first. Now, this printer, this device, is actually a scalable frame, meaning that it was designed so that you can change the dimensions of it very easily to your wishes. So you can change the X dimension, which is across, you can change the Y dimension, which is the depth, and then you can change the Z connection, which is the height. It was designed such that we have these nodes over here. So these nodes are all symmetrical. And so this side is an exact copy of this one. Not even a mirror image, but an exact copy of this one. This end over here for the X is an exact copy of this one. Then you have these extenders, which are exact copies of each other. And then you have this motor block, which is just at the center, and it's kind of like this symmetry. And the same thing with all the lower parts of the printer, including the Y. One of the other goals for this is to have it be under 100 parts. So we've succeeded in that goal. This is just about 100 parts. I think we have 97 parts right now. Kind of lost count. But but anyway, that's our goal. And all the plastic on here is actually made from compostable materials. So this is PLA, polylactic acid, which is made from plant matter. So what are some of the other features I can tell you about? So it's also very portable. So let me move this up here. So you can fold it and stow it. Also, it has removable parts that are easily swappable. So right here, this is the goo extruder, which extrudes goo. And inside of the goo extruder, we have some almond butter right now. And this is inside of a syringe. So this is a basic linear actuator where the base and the top of it are 3D printed. And it uses standard off-the-shelf parts. So this is an 8mm smooth rod. This is an 8mm threaded rod, and this is a geared stepper motor. And the reason why I use a geared stepper motor is so that it can very easily extrude thick materials, whether it's something like almond paste or ceramic. Or you can also use other types of biological materials. So you can use this not only for making food or for pottery and ceramics, but also in the lab, where you can have, you can extrude exact amounts of a sample into a petri dish or whatever it is that you need to do. And the other thing is that we have these hot shoe camera mounts. So I used to be very involved in the film world, so I knew all about these wonderful camera mounts. This is actually a copy of a Manfrotto Mount. And I thought, we'll just put this on here and be very easy to snap on. Let's see. Of course, there we go. Okay. So, the other thing about this that's, I guess, kind of unique, let's see, we'll move it down a little bit. So I was thinking about how to affix the X carriage such that you can take it apart very easily. So this printer is, it's really tightly held together, and you wonder, well, what's actually holding it together? As you can see, there aren't any metal fasteners holding the top bar, the bottom bar together. So what's holding it together? Well, here's the unique thing about it. Basically, we can take off the X carriage because we actually use neodymium magnets. So this is a magnet right over here. There's a magnet over here. And so it will slide in very, very easily to the carriage. And you slap it together. And once it's slapped together, it's very, very difficult to pull apart. So it's actually very easy to keep this level. And yeah, let's see. And so I wanted to give a huge shout out to my design partner on this, the ever illustrious Lucian Chapar, who is an absolute genius when it comes to machine design. It's been a pleasure to work with him on this project. It's always important to have a really good partner who's able to put the work in and has amazing skills. So I just wanted to give him a huge shout out. And the whole purpose of this really was to be used in the Groucho Fractal show. Groucho Fractal is a performance that I do, which is a bicycle-powered stage show where audience members use brain-computer interface to make 3D printed organic vegan snacks on a bicycle-powered 3D food printer. So I didn't have any of those things at the time, so I had to invent a lot of them. I also had to meet people who were making these things. And so thus began a huge journey. So anyway, now I have this 3D food printer. The other thing about it too, which makes it ecologically friendly, is that it is low power, so you can power it via bicycle. So you can basically pedal a bicycle, and I have a power unit that I developed with a few friends that has batteries and supercapacitors combined, so that you pedal, you charge up the pack, and then you can run the printer. It's actually easy to run this printer with this configuration because we don't have a hot end. We don't have a heated bed, which tends to take up a lot of the electricity. Really, all we have on this are 4 stepper motors. So it's fairly simple to power. Oh, also we have this microcontroller. One of the other things too, which was a very important design decision, was using a RAMPS 1.4 controller board on top of an Arduino Mega 2560. Now, the reason for that is that this is cheap and ubiquitous. You can buy these for $5 very, very easily. And so I wanted to make this printer very accessible. So somebody could just take something that was already in a hackerspace or they might have in a drawer and get it running. So a lot of the inspiration for this project comes from, awesome projects like Linux, like open source ecology, and RepRap, of course. This I would say it could be considered a RepRap. I would hope it would be considered a RepRap. It's a potentially self-replicating 3D printer. And these are some plant-based organic cookies we have on this print bed. And what I'm about to do is I'm about to set the dimensions basically so that I can control where the print is going to go. So we're going to program that, and I'm going to be sending the coordinates over to Lucian so he can write a lot of the G code that we're going to need. It's kind of amazing being able to coordinate with people across the world using the digital interwebs. Let's see, I'm going to send this to Lucian right now. Okay. Perfect. Okay. And I'm going to send the coordinates. Let's see, 13 millimeters for the Y. Okay. Yeah, so I don't know, I like being able to actually coordinate with other people when working on stuff. I should probably be able to do this myself, but you know, I really like collaborating with people too. Oh, actually, Lucian is saying that these are Cartesian cookie coordinates, CCC. Of course. Yeah, I guess that's one of the best things about like having people around who are like fantastic to work with. Like, I hope we get to work together. You have such like a good energy about you, and I don't know. I feel like you get the complete insanity that this thing represents. It's kind of like, I guess, the anti-capitalist machine or something like that. Yeah.
Yeah. First step in the direction of making it like accessible.
Yeah. Yeah. One of the parts that I left out about this that I'm working on. So this, aside from this project being parametrically designed and scalable, there's a specific reason for that. One is that I wanted us to be able to make the scalable printer. Now, we can just export the files. I mean, we will be able to do that so that people can have the cut files, the build files, and the programming for the microcontroller. But in addition, one of the other goals is to also have a smart contract. So I want to actually produce NFTs on some blockchain that can support NFTs, where we output all those files and then add an additional component to it of governance. So one of the things I'm a huge fan of is collectivism or cooperativism or other types of voting systems or like, I guess, governance in human organizational systems that allow for greater fairness in projects, such that we have things like quadratic voting and all these other types of interesting experiments. Yeah. And so a lot of the technologies that come out of the cryptocurrency realm, like blockchain tech, allow for this type of organizational system to become scalable. So we can experiment with that scaling process. And that's one of the things that we're going to be doing with MandelBot, is that we're going to be exporting those files onto a smart contract and figuring out how that actually works. And by default, it will allow people to organize collectively versus in I guess hierarchical ways. And the people will, if they want to actually do stuff where they have hierarchies, they'll actually have to hack the code themselves to do it. But by default, it's horizontal and designed to be fair. And I'm sure that's going to infuriate a lot of people, but I think that it's really important to challenge people to think about these things. But yeah, that is, I guess that's in a nutshell the MandelBot project. Coming up soon, we have the MandelBot Hab, which is a 3D printer for ecotecture. That's large-scale 3D printing of buildings using natural materials. And that's like a whole other project. And also, I'm working on a platform for flying electric vehicles that are also scalable, where all the engineering and other aspects are programmed into it. So, yeah, I'm just kind of hoping to inspire people to start thinking about design in this way, where you're not just looking at an object and thinking like, oh, that's a toaster, oh, that's a speaker. But I want to start having people think about every single object that's been designed that uses mining or like extraction or any of this stuff that brings these wonderful materials to us, to start thinking about all these devices as multi-purpose materials or multi-purpose devices that are easy to repair, easy to build, easy to reuse the parts and recycle everything, and such that we stop thinking about anything really as waste, and that everything itself is a resource. We have to kind of go back to that way of thinking so that we can survive and that we can start to thrive and travel to other planets and avoid making a lot of the same mistakes that we've made over the past 150 years or so. But we can correct it, we can figure things out. But yeah, over and out. Thank you very much to SGMK. You guys are amazing. CCC, you're amazing. So happy to be here and honored to be a part of summer camp. Yeah, Homemade Summer Camp is really such a great event. I can't wait to come back in future years. And maybe you'll be eating some goo from the goo strudel in the future. Okay, bye. Oh, last thing I'll leave you with. The reason why it's called MandelBOT is not only because we're printing with almond paste, but also it's a tribute to Benoit Mandelbot, who described the Mandelbot set of fractals that are named after him, that are scalable, iteratable, modular. So the printer was designed to follow a lot of those patterns that we find in nature. Yeah, keep looking up. Thanks so much. Mandelbot.io. My name is Scott Beibin, spelled SCOTTBEIBIN, and that's Scott, SCOTT, at Mandelbot.io. Okay, thanks, bye. And at Groucho Fractal, if you want to contact me on social media. Thanks.